Good afternoon. This is Ahmed Bahadin again, and today we are going to have another rate of change questions in calculus. A cylinder with a radius r and height of h. If the radius is increasing at a rate of 4 centimeters per second, what will be the decreasing rate of the height to have the total surface area constant at 600 pi centimeters squared when the diameter is 20 centimeters? And now I'm just putting these information here on I put the information on the board. So this is the radius, height, circumference, which is 2 pi r. Total surface area is going to be constant, 600 pi centimeter squared. If the diameter is 20, so I have the radius 10. And I have the rate of the change of the radius, dr over dt, 4 centimeters per second. I need dh over dt. That's what they needed at when the radius or the diameter is 20, so the radius is going to be 10 centimeters. So I'm starting with the equation of the total surface area, which is the bases plus the surrounding. The bases, both bases are circles. So I have pi r squared times 2. And this is the circumference. If I open this side of the cylinder, that's the side of the cylinder. This one here is going to be the circumference, and this is going to be the height. So that's why I am multiplying the surrounding, and there's a circle as a base here, another circle as a base there. Do you see that? So this is going to be a rectangle, and the length is circumference, and the height is h. So I can substitute and make it 2 pi r squared plus 2 pi r times h, and the total surface area from the question is 600 pi. So now I am trying to solve for h with respect of r. So if I take 2 pi here as a common factor, so I'm going to have here only r squared, and here is going to be rh, and I have a 600 pi on the side. I can divide by pi each sides, so dividing by pi, then I divide by 2 also, so I'm going to have a 300 is equal to r squared plus rh. Well, I can now solve for h. I can move the r squared to the other side, so I can say that 300 minus r squared is equal to rh, or rh is equal to a 300 minus r squared. Now I can divide by r again, so to get the h in terms of r only. So I'm going to have 300 divided by r minus r squared divided by r is going to give me only r. That's the relation relating the height of the cylinder with the radius of the cylinder. Now I am going to take the derivative with respect to the r. So I take dh over dr, which is going to be, now if you take this to the top, that's going to be a 300 r to the power of minus 1. So I am going to say that it is minus 1 times a 300 r to the power of minus 2. And this is going to be only 1, because the derivative of r is 1 with respect to r. I reorganize this, and I make it minus a 300 over r squared and minus 1. That is actually the value of dh over dr. Now to find, at the end of the situation, to find the dh over dt, I can rewrite that a dh over dt, the change of the rate of the change of the height with respect to the time. I am going to say that I can rewrite it as a dh over dr, and I have this one here, which is I can use it for myself, and I put it here dr over dt. So I have dr over dt, which is 4 centimeters per second. Well, dr over dt is going to be only 4. I am going to substitute 4 in here. Let's substitute whatever we have here, which is negative 300 over r squared, and that's going to be minus 1. Let's multiply this, all of it, by the dr over dt. So I'm going to rewrite it this way. And now this is my change of the height with respect to the time. Now I know that my radius is equal to 10 in here. So let's substitute r equal to 10. So that's going to be negative 300 over 100. 2 zeros from here, 2 zeros from here. And that's going to be minus 1. So I'm going to multiply all of this by 4. And the end of the situation, negative 3, negative 1 is going to be negative 3 plus negative minus negative 1 is negative 4, and that's going to be multiplied by 4. So the answer is going to be negative 4 times 4 is negative 16. Negative 16 exactly, and that's going to be centimeters per second. So that is going to be the rate of the change of the height with respect of the time when the diameter is 20 centimeters. Thank you so much.